Here's another important element you guys need to think about, and that's the encapsulation process. Before I describe the encapsulation process, another term that's important for you to understand is called PDU, Protocol Data Unit. And data within the OSI model at each layer is called PDU. So PDU for layer 7, PDU for layer 6, PDU for layer 5, so on and so forth. So that's a generic name given to data at each layer. That's how it's represented. The top 3 layers in the TCP/IP model are combined into application. This user has an email that needs to be sent to the computer on the right. It's going to send data. When this data gets to the transport layer, or layer 4 of the OSI model, is called a segment. And transport layer is going to add a header to it, a TCP header. When it gets to the network layer, it's called a packet, and it's going to add an IP header. When it gets to the data link layer, it's going to add Ethernet header to it. And finally, the bits that get transported across the wire to the other side. And then the other side looks at the bits, looks at the MAC header, removes it, then sends the data upstairs, goes to the LLC header, which once again, LLC and MAC combined are Ethernet. So once the Ethernet header is stripped off, the packet is sent to layer 3, looks up IP, removes the IP header, sends it upstairs to the transport layer. Transport layer looks at the TCP header, removes it, and finally sends the data to this guy right here, who's able to read that email. This is how this communication happens. Now, the process on the left is called encapsulation because we're putting envelopes or headers on top of the data. The best analogy I can give you is the post office analogy. When you take your package to the post office, they stick a label on it and they provide you with the tracking number. Think of these headers that are added to the data as envelopes. And there's layer of envelopes that get added when the data travels from north to south, from application down to the physical layer. That's called encapsulation. But when the bits get to the other side starts to remove the headers. That's called decapsulation, the removal of headers. And the addition of headers is called encapsulation. So I just want to make sure that you guys get these two concepts, because most likely it's a good exam topic, but also from a real world perspective, it's good to know. Now, what's the purpose of the OSI model? For me, it's 3 things. First, interoperability. Now, that's a mouthful, but what does that mean? That means if I take a Cisco switch and connect it to an Arista switch, when they're connected together, they need to be able to talk to each other. I don't want these companies using their own proprietary technologies, because then that locks me into that vendor and I do not have the ability then to do anything. And as an enterprise, as a government, or any type of business entity, I need to have that flexibility to be able to interoperate. So that's what the OSI model gives us. The second thing it gives us is a common set of language that can be used by these different vendors to continue producing great networking products that operate with different set of standards. So for example, layer 1 has its own physical layer standards, and layer 2 has its own standards, and layer 3 has its own standards. So when you're looking at a device that operates at layer 2, for example, it is only designed with layer 2 in mind. It doesn't have any intelligence of layer 3 or layer 4 or any of the layers above it. All it's concerned with is layer 2. So that is an important element. And that's what also helps with the interoperability, because that common language then allows these software engineers and these hardware makers to produce products that can talk to each other and integrate and interoperate. And finally, for me, the big one is troubleshooting. So let's say if you have a user who says, I can't access any website. Well, that means their internet is down, right? That's the first thing that comes to mind. But how do we test if it's just the internet or maybe something else going on? What we do is we have two different approaches. One called top-down approach from a troubleshooting standpoint, and the other is the opposite of that, bottom-up approach. And with these approaches, what that means is top-down means you start at the application layer and then you work your way down. Bottom-up means you start with the physical layer and work your way up. Both approaches are valid. It just depends what you are troubleshooting, and based on the information that's given to you, how fast you can get to the resolution of the issue that you're trying to address. That's what it comes down to. And as network engineers, like I said, we're primarily concerned with 4 layers. So for us, that's the focus area, because layer 5 through 7 is primarily used by software developers and programmers for designing and writing code. Hope you enjoyed today's video. If you did, give me a thumbs up, hit subscribe, and I'll see you in the next video.